So joint variation just means you can have more than one variable that it's related to. So like you already have two variables, x and y, but now you could say, well, y varies directly as x and inversely as z, or you could have them be jointly both direct and just multiply them. I'll give you an example. That's probably easier. Let's say you have a volume of a box, and you know the volume is length times width times height of a box. And let's say you know the length is going to be 10 feet. And so now you could say, well, the volume varies jointly as width and height. And then, you know, okay, well, I'm going to multiply width and height. That is what we mean by varies jointly. And your k in this case would be the 10. That would be your constant of proportionality. Now you could say, whoa, what if I didn't know the length? Yeah, you could say the volume varies jointly as length, width, and height. So you're going to be multiplying those together. Now in the example I was talking about, we said something like, oh, y varies directly to x and inversely to z, something like that. Then we could say, well, y equals k. You're always going to have a k. Kx over z. That would be an example of that. So it just means there's more than one variable that it's varying to. You have lots of variables. Okay, so their examples, they're not very story-ish. They just say x, y, and z, and they give you the values. But I have a couple examples at the end where we can see some more practical applications. But here's an example of a joint variation problem. So the quantity x varies directly. Okay, so x varies directly, like you could just put the equal sign right there. And then you have to have a k. K varies directly with the square of y. Now you've got to think, okay, y squared then, because it's the square of y. And inversely, okay, that means it's going to be in the denominator, with the cubed root of z. Oh, cubed root, okay, cubed root of z. Okay, there's the formula then. It's a little more complicated than the other ones we were doing, but if you take it piece by piece, it's going to be okay. So x varies directly. X is equaling something, and we throw the k in because we have to have a constant of proportionality. And it varies directly with the square of y. That was our y squared. Because it's directly, that's in the numerator. And inversely, that means this next part's going to be in the denominator. And it's the cubed root of z. So I have to make sure it's a cubed root, not cubed. Okay. All right. And then it says, if x equals 6 when y equals 2 and z equals 8, they have to give us all the variables so we can find k. The steps are still the same. We set up the model. That was step 1. Now we know x is 6. We don't know what k is. We're going to figure that out. Y was 2. And z is 8. So you're following this model that you have, and you're plugging in x, y, and z, and you're going to be able to figure out what k is. So we get 6 equals 4k over 2, or 6 equals 2k, so k must be 3. Okay, now we can write the formula. Now we can go up here and we say we know what k is. The model is going to be the same, except for that k now is going to be a 3. There's our formula then. Now they can tell us like y and z, and we can figure out x, or whatever two variables they want to give us. Okay, so it says find x. Okay, so we're going to be finding x. it says y is 1. So we have 1 squared. And z is 27. So the cubed root of 27. Okay. So they give us nice little numbers to work with here. So we get x equals 3 times 1, which is just 3. And the cubed root of 27 is 3. So it looks like x is just equal to 1. Not very exciting, but they could have given us some other numbers, but just trying to take it easy on us, I guess. Okay, so that's how the steps go. Write the model. That's step 1. Figure out what k is. They have to give you enough information to find k. Then you get the formula. And then they are going to give you 2 of the 3 variables. It depends on how many variables you have. They'll give you all the values for all the variables except 1. And then you're going to figure out what that is. So just solving an equation.